our second day on the chapter Polynomial. In the previous class, we have solved some basic problems on polynomial. Today, we will learn about a new theorem known as Factor Theorem. Factor Theorem states that let fx be a polynomial of degree greater than 1 and a be any real number. Then if f of a equals to 0, then x minus ea is a factor of fx. That is, fx is a polynomial. In the previous class, we read that by remainder theorem, when fx is divided by x minus a, the remainder is f of a. That is, fx when divided by x minus a, the remainder is f of a. F of x divided by x minus a, quotient is dx and remainder is f of a. Now, if f of a is 0, then this becomes fx equals to x minus a into gx. Hence, clearly x minus a is a factor of fx. That is, by factor theorem, when fx is divided by x minus a, if f of a becomes 0, then x minus a is a factor of fx. Let us take an example on this theorem to understand clearly. For what value of a the polynomial 2x cube plus ax square plus 11x plus a plus 3 exactly divisible by 2x minus 1. Here the given polynomial is 2x cube plus ax square plus 11x plus a plus 3. We select this as fx. Now 2x minus 1 equals to 0 gives x equals to half. By factor theorem, fx is exactly divisible by 2x minus 1 if f of half is 0, because here a is half, so we have to find f of half equals to, put the value of x as half in fx, that is 2 into half whole cube plus a into half whole square plus 11 into half plus a plus 3. Half cube means 1 by 8. Half square means 1 by 4. This is 11 by 2 plus a plus 3. To multiply 1 by 8, that means 1 by 4. This is a by 4 plus 11 by 2 plus a plus 3. Now by factor theorem, this expression must be 0. Therefore, 1 by 4 plus a by 4 plus 11 by 2 plus a plus 3 is equals to 0. To add all we find the LCM as 4. 1 plus a plus 22 plus 4a plus 12 equals to 0. Adding, we get 35 plus 5a by 4 equals to 0. That means 35 plus 5a equals to 0 implies 5a equals to minus 35 implies a equals to minus 7. So we get the value of a as minus 7. When f of x is given, we divide it by 2x minus 1. By factor theorem, fx will be exactly divisible if f of half is 0. So we find the value of f of half and make it 0. By this we get the value of a as minus 7. Our next discussion is about factorization. Factorization is an important part of polynomial chapter. Factorization means we have to factorize a given polynomial. We can factorize a polynomial by many methods. First, we discuss one method by taking out common parts or by grouping. Take an example. A cube plus a minus 3a square minus 3. Here you go. We grouped a cube minus 3a square together and a minus 3 together. Now take the common part out, that is a square. And here no common part, so take out 1. A minus 3 is common in both, so take out a minus 3, the remaining part here is square and here plus 1. So after factorization of this polynomial, we get the factors as a minus 3 and a square plus 1. Clear? Now come to next type. Type 2 is polynomials of the form x square plus bx plus c. When a polynomial is of the form x square plus bx plus c, that is of the form quadratic trinomial, then we find two integers p and q such that p plus q equals to b and p multiply q equals to c. then the polynomial will become b means p plus q and c means p multiply q. Splitting up x square plus px plus qx plus pq. Now take x common, x plus p, and here q x plus p. So the factors are x plus p and x plus q. This is the method of factorization of polynomials of the form x square plus bx plus c. Let us take an example. X square plus 7x minus 18. Now the given expression is x square plus 7x minus 18. Now we have to find two integers, that is p and q, whose sum must be 7 and product must be minus 18. Clearly, 9 plus minus 2 equals to 7 and 9 multiply minus 2 equals to minus 18. That is the two integers 9 and minus 2. The sum of them is 7 and the product is minus 18. So, x square plus 7x minus 18 equals to x square. In the place of 7, we can write 9 minus 2. And in the place of minus 18, we can write 9 into minus 2. X square plus 9x minus 2x minus 18. Now taking x common, x plus 9, and here taking minus 2 common, x plus 9. So x plus 9 is common in both the term. X plus 9 into x minus 2. So here, when the polynomial is of the form quadratic trinomial, we find two integers where the sum of the integers is 7 and the product of the integers is minus 18. And putting the value of the integers, we split up them and taking common, the factors become x plus 9 and x minus 2. So here we complete some method of factorization. Thank you everyone.